Alright, so if we look at the periodic table with oxidation numbers, we see that germanium has two possible oxidation numbers, 4 plus and 4 negative. So the question is, from this orbital notation, where do we take the electrons from to get that 4 plus charge? Well, the answer is you take it from the highest primary energy level first. And what's the highest primary energy level? 4. So these two and these two are going to go away first. Okay, so to get the germanium 4 plus charge, we're going to have 1s with 2 electrons, 2s with 2 electrons, 2p, 3 orbitals, 6 electrons, 3s, 1 orbital, 2 electrons, 3p, 3 orbitals, 6 electrons. Then 4s is going away. We keep 3d, 5 orbitals, 10 electrons, and 4p is gone. So that's the ion germanium 4, or 4 plus. Okay? Got that? Now, what if we want to use the germanium with the 4 negative charge on it? How are we going to do that up here? Finish filling up 4p. Okay, so for that, then we're going to have germanium 4 negative, 2 electrons in 1s, 2 electrons in 2s, 3 orbitals and 6 electrons in 2p, 1 orbital, 2 electrons in 3s. We're keeping 4s. I'm sorry, you got to do 3d first. I call that 3p. That's 3. Yeah, that is p. Sorry. Yep. All right, 3p. Run out of time. I'm trying to rush a little too fast. We're going to keep 4s. 3d's remaining. No change. 2, 3, 4, 5. I'm sorry, I didn't put the 5th one in there. And 4p gets completely filled up. Okay? And you should be able to write the electron configuration orbital notation for both of these. Right? So the electron configuration is the condensed version of this. 1s2, 2s2, 2p6, 3s2, 3p6, 3d10. That's germanium with a 4 plus charge. Germanium with a 4 negative charge, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. Does that make sense to everybody? Yes? Alright. So sometimes you got some odd numbers in there and you can still figure out what the charges are going to be and how the orbital notation electron configuration should be done. Now with scandium we did before, we had to have a 3 plus charge. Okay? So the only choice was to take the 2 out of the highest energy level and 1 out of 3D. Okay, that makes sense? But here, in order to get to a 4 plus charge, we didn't have to take anything out of 3D if we take it out of the highest energy level first. So if you remember the rule, take it out of the highest energy level first, you'll be fine. Okay with that. You should be fine as far as your predictions are concerned. Does that make sense to everybody? Think you got it? Yep. Can you remember when you do your homework tonight? Huh? Yes, what would be the negative one called? Germanide. Yeah. Something like that. Germanide. ON just means orbital notation. EC is electron configuration. Write the orbital notation and electron configuration for the atom and ions of silicon. Then write the names and symbols for all. Positive ions are just called ions. Negative ions, you change the ending to IDE. And somebody explain that connection between that and women who get married and change their name. Tyler, for me, will you? No. Really?
No.
Okay. I don't know if it's, well, in the United States, typically, not always, when a man and woman get married, the woman changes her name to match the last name of the guy.
Right.
So the woman changes her name to match the name of the guy, right?
Yeah.
Negative ions change their name when they get a negative charge.
Okay.
That's all there is to it.